previous video, I explained about first come, first serve scheduling algorithm, its advantages and as well as disadvantage. What is the disadvantages? So the disadvantage is, suppose, so how this first come, first serve work? So the processes which arrives in what order, in the same order the process will execute. That means which process comes first, that will complete, then only the next process. Okay, the what order they arrived, what order they came, in that order only they are executed. Suppose if these processes P1, P2, P3, P4, these processes arrived at the same time in this order, and suppose the first process consuming too much of time, then all the remaining processes has to wait for the long time. See, just you see this one table, we already saw it in the previous video. So to execute 4 seconds, it is waiting 20 milliseconds. To execute 5 seconds, it is waiting 24 milliseconds. To execute 3 milliseconds, this is waiting for 29 milliseconds. Now, if you take the average waiting time of each process is about 18.25 milliseconds. Similarly, the average turnaround time is 26.25 milliseconds. Now, this is the disadvantage. Means if the initial process, whichever came the first assigned process, if that process is taking too much of time, then all the subsequent processes has to wait for the long time. So, even though they need very, very short CPU time also, they have to wait for longer time. So, to overcome this disadvantage, see what we did, we make the order of this processes in different order. So, I put the process which is consuming more time at the end. Suppose the same process arrived in this order at the same time. So then what? So I put the process which is taking too much of time at the end. So now if we do like this, now average waiting time reduced from 18.25 milliseconds to 6.25 milliseconds. See, 3 times almost it reduces, divided by 3. Okay. Similarly, so average turnaround time from 26.25 milliseconds to 14.25 milliseconds, almost half of it reduces. But still we can. So now what is the thing here? So in this one, so simply I did what? I make the process which is taking most amount of time at the last. But still we can reduce. So how? So instead of making the process to execute in the order of their arrival, okay, in what order they came, instead of that, if we execute the process which consumes which are lesser time, okay, always execute the process first which taking shortest time. So if you observe that, so then that type of processing scheduling algorithm is called shortest job scheduling first. Okay, shortest job first. That means shortest job first scheduling algorithm. That means you execute the process which needs shortest time. Okay, so execute the job process which requires very, very small first, then the next small, then the next small. So like that, now that type of scheduling algorithm is called shortest job first. And this shortest job first may be what? Maybe non-preemptive or it may be preemptive. Okay, preemptive or it may be it may be preemptive or it may be non-preemptive. Now let us discuss first non-preemptive. Okay, so now in this video I am going to explain about what is shortest job first, that we know already, how it reduces. Okay, now the same thing. Okay, now what I will do, assume let us say same this process. Okay, this process only, but these process are at the same time. Let us take arrival time is equal to 0. Now let us write the Gantt chart for this one. Okay. Now let us apply for this one shortest job first. What the shortest job first says? The shortest job first says execute the process which requires shortest time, least time. Okay, that one first. Okay, now among this one, which process take least time? 2453. P4 requires only 3 milliseconds. So now I write Gantt chart here. Okay, so Gantt chart. So start with 0. So because all arrived at the 0 time, all are there at the 0 time. Now among these 4 processes, this requires less time. So start with first P4. So P4 will take how much time? It is only 3 milliseconds. 0 plus 3, 3. So P4 is done. So now, since now I'm doing what? Non-preemptive scheduling job first. Non-preemptive. That means once you start a process, until its completion, we should not stop in between. So next what I will do, so now this is done. P4 is done now. P4 is done. Now among the remaining P1, P2, 3, which is at least 1, P2 is requires 4. That is the least. So P2 requires what? 4 milliseconds. So 3 plus 4, 7. So now P2 is also done. Now remaining what? Only P1 and P3. Among P1 and P3, which is shortest job, so it is 5 milliseconds. P3. So I will start P3. Okay. So it requires, P3 requires 5 milliseconds. 7 plus 5, 12. Okay. Next, P3 is also done. Now remaining only one. So now I am executing process 1. So it requires 20 milliseconds. So 12 plus 10, 20. 32. See, if you observe all the variation, the first variation, first come, first serve. Same thing, 32, last 32. And if I put the process which consuming more time at the end, then also last 32. But totally almost same. That means the total last process ends should be 32 only. Now let us calculate waiting time. Now, P4, now here, P4. So P4 came at 0, started 0. That means P4 starts at 0 only, came at 0 only. So how much waiting? It doesn't wait it. No waiting time for this. Doesn't wait. So immediately starts. So waiting time is 0. Now let's say P2. P2 starts at 3 seconds. That means it waited because it came at 0 second only. So it waited till 3. So then start. That is 3 minus 0, 3. So waiting time of process P2 is 3. P2 is 3 milliseconds. So next P3 starts. P3 starts at 7th millisecond, but it arrives at 0. 7 minus 0, 7 milliseconds. So P3 is 7 milliseconds waiting time. So last P1 starts executing at 12th millisecond. So it is 12. So now if you do addition of all this, 12 plus 3, 15. 15 plus 2, 22. So 22 divided by what? 4. 22 divided by what? 5.5 milliseconds. So this is the average waiting time. Okay, if you apply shortage of first. So that, see, from 18.50 we reduce it to 6.25. From 6.25 reduce it to 5.5. So this is efficient in terms of waiting time. Now let us calculate turnaround time. So turnaround time formula is what? Total waiting time plus total execution time or the burst time, this burst time. Okay. So now waiting time is 12, this is 20, so this is 32 milliseconds total turnaround time of process 1. So 3, waiting time 3, execution time 4, 3 plus 4, 7, 7 plus 5, 12, 0 plus 3, 3. Okay, now add all this, divide by 4. Okay, so now it is 39, 39 plus 12, 51. 54. So 54 divided by 3. So okay, 54 divided by 3, how much? It is 18. Okay, 18 milliseconds. See, average turnaround time. Sorry, not 15 by 4, 55 4 by 3, 54 by 4 it is. So 54 by 4, how much? 13.50, 13.5 milliseconds. See, it is from 14.25 to still we reduce it to 13.5 milliseconds. So this is what the turnaround time. Let us say calculate again response time since arrival time is in start time. So P4, okay, P1 starts at what? P1 starts at 12. Okay, 12 minus out is 0, 12 only. Okay, so then P2 starts at what? 3 milliseconds. So 3. So P3 starts at what? 7. P4 starts at 0. Exactly same as waiting time. For almost most of the problem, response time will be the same as the waiting time. Okay. So now that means if we apply shortage job first, so we can further reduce the time taken. That is average waiting time and as well as the turnaround time. But here what we need to observe is we use what? Non-preemptive concept of shortage job first, because shortage job first may be non-preemptive or it may be preemptive. But whereas first come first service compulsorily non-preemptive only, it cannot be preempted. Because whichever comes first, we have to execute. Here, we are executing the process which requires very less time first. then the next second list. Okay, this is what shortest job first. Okay, now let us apply same thing, shortest job first only, now with preemptive shortest job first. Now let us take this one now. For the now we are discussing what shortest job first, preemptive. So earlier what we discussed, non-preemptive version of shortest job first. So once we started, even though after some time if any new process come which requires less also, we should not stop in, but we should continue. That is what non-preemptive shortest job first. But here in the preemptive shortest job first, so once it starts, suppose after some time some another process comes and that requires very less time than the currently executing, so we have to stop this one and have to take up the new one. Okay, let us discuss this one. Okay, so now for this arrival time is different now. Arrival time is different. Now the arrival time is different. Now for this let us again need to calculate what? Waiting time. Then turnaround time we are calculating. Okay. Now let us write for this what? Gantt chart. So now Gantt chart, I will start with what? 0. Now at the 0th time, so okay, always I will take in terms of milliseconds. Okay, milliseconds. So at the 0th millisecond, process P1 arrives. But process P2 comes at second millisecond, 2 millisecond. But 0th millisecond, this is the only process. We don't have any option. I have to start what? Process 1, I have to start. But I keep starting at 1 millisecond over. At exactly second millisecond, now one more process comes, which is that at second millisecond, process 2 comes. When process 2 comes, now it requires how much? 8 milliseconds. But process 1 requires how much? 20. Out of 20 already is executed for 2 milliseconds. It requires remaining only 18 milliseconds. 18 milliseconds, it requires 18, which is shortest one. So again we'll continue. Okay, now I'll stop P1 and I start P2. P2 I will start. When I start P2, it requires 8 milliseconds. Immediately at the third millisecond, one more process arrives now. One more process, which is a process P3. P3 arrives, it requires 5 milliseconds. But P2 requires 8 milliseconds totally, but it is already executed for 2 to 3 minutes. 1 millisecond executed, that means it requires remaining 7 milliseconds. And so it requires what? How much? 7 milliseconds. It runs for 2 milliseconds, 18 milliseconds, it requires 5. So 18, 7, 5, which is shortest? 5. So I stop P2 at the 3 millisecond. Immediately I started what? P3. Now P3, so executing, so immediately at the next second, at the 4th millisecond, another process arrives, which is that P4 arrives. Now P4 arrives, now it is executed for how much? Process 3 executed for 1. Process P3, 3 to 4. 1 millisecond. That means it requires the remaining 4 milliseconds. But it requires only 2 milliseconds. Now 18, 7, 4, 2, which is shortest. P4 is shortest. So I stopped forcefully P3 and I took the last one, P4. P4 I took at the 4th millisecond. Now that's it. Now remain the next one, no process is there. I will continue 5th or 6th. Okay, at the 6th millisecond, process P4 completes its job. P4. Now once P4 completes its job, next I will check again. Now all 3 are arrived now. Everything is arrived. Now among the remaining process, so 4, 7, 18, which is shortest remaining, so P3. So again I will start P3. So P3 requires how much remaining? 4. Because out of totally 5, already here 1, here 4, 6 plus 4, 10. So P3 also completes. Once P3 completes, then I check which is 18, 7, which is minimum P2. So I start P2. So it requires 7. So 10 plus 7, 17. So this is also done. Okay. So totally P2 requires how much? 8 millisecond. 8 millisecond here, 10 to 7, 10 to 17, 7. And then here 1. Okay. So P2 here and here. Here 1 millisecond, here 7. So totally 8. So now remaining what? P1, it requires another 18. So 18. So P1, 18 plus 17, 35. Done. Okay, now this is the Gantt chart. Now from the Gantt chart, now we need to calculate how much process P1 waits, how much process P2 waits, how much process P3 waits, how much P4 waits. Let us say P1 comes. Okay, P1 waits for how much time? So now here, except P4, remaining all are two occurrences are there. See, except P4, P3 appears twice, P2 appears twice, P2 appears twice, P1 appears twice. Okay, now calculating the arrival or what waiting time, go to the last occurrence of the process. Now I am calculating the waiting time of process 1. Process 1, so here it is there and here it is there. So which is last? This is the first occurrence, this is the second occurrence and the last occurrence. So go to the last occurrence of the process, P1 event. Here P1, that means waited for 17 milliseconds and then starts execution, completes. So but 17 minutes, after 17 minutes P1 it starts. But before that P1 is there, yes P1. But here it executes for 2 milliseconds. So 2 milliseconds means 17 minus 2, 15 milliseconds. Okay, so 15 milliseconds it waited. Which one? Process P1. See, go to the last, again, this is a commonly done mistake by the students. Go to the last occurrence, P1 appears first time here, second time here, this is the last occurrence. So 17 time, after 17 milliseconds, it start executing. That means it waited for 17 milliseconds. But during the 17 milliseconds, it runs. So P1, the last occurrence, so it starts at 17 milliseconds. So that's the last occurrence. Starting time is 17 milliseconds. Minus, in the previous you check, P1 is there anywhere? Yes, it is there here. So it executed for 2 seconds. So 17 minus 2 seconds. So start time minus execution time. So 17 minus 2, 15 milliseconds. Minus arrival time. So because P1 comes at 0 time, so 17 minus 2 minus 0, that is 15 milliseconds. Okay, so I'll write P1 waiting time is equal to, it starts at 17 milliseconds, minus it executes for 2 milliseconds, arrival time is 0. Okay, so this is what we know. So this is the start time of the last occurrence. So this is the execution time and this is the arrival time. Okay, so now, similarly for P2, see, now check P2, once it is there, then it is there, so 2 occurrence. So this is the last occurrence. So last occurrence starting time is how much? 10 milliseconds, P2, okay, 10 milliseconds minus its execution time. Comes, okay, whether check whether it executes. Yes, it executes for 1 milliseconds, 2 to 3 P2. So 10 minus 1, minus it arrived at what? It arrived at 2 milliseconds. So it is minus 2. So 10 minus 1, 9 minus 2, 7. So 7 milliseconds waited totally. Okay. Similarly, check for P3. Okay, P3. Now check P3 how many times? See P3 1 and 2. 2 times it is there. So this is the last occurrence. Last occurrence starting time is what? 6. So 6 minus it executes. Yes, executes for 1 milliseconds. 1, but it added at 3 milliseconds. So 3. So that means 6 minus 1, 5. 5 minus 3, 2. So 2 milliseconds it waited. So similarly, the last process P4. So P4 is here only one occurrence, only one. So its start time is what? 4. So 4 milliseconds it executes. Executes previous it not executed. So 0 minus it arrived at what? 4th millisecond. 4. That means 4 minus 0, 4. 4 minus 4, 0 millisecond waited. That means P4 arrives at 4th millisecond and executes at 4th millisecond. It doesn't wait it. So okay, this is how to calculate the waiting time of the individual process. Now I need to calculate the average waiting time. Add this 15 plus 7, 22, 22 plus 2, 24, 24 divided by 4. So 6 milliseconds. This is the average waiting time. For this problem. This is a new problem. Okay. Now the turnaround time. So how to calculate turnaround time? The same formula. Turnaround time formula is what? Waiting time, total waiting time plus its execution time. Okay. Total waiting time is what? 15 milliseconds. Execution time is 0. Okay. Now this is arrival time. 15 plus 20. So it is 25. Okay. 25 milliseconds. 15 plus 20, 35. 35 milliseconds. Then 8 plus 7, 15. So 5 plus 2, 7. 2 plus 0, 2. So turnaround time is equal to total waiting time of the process and total execution time. So waiting time 15, already we calculated 20, 35, 8 plus 7, 15, 5 plus 2, 7, 2 plus 0, 2. Now average waiting time again 35 plus 15, 50, 57, 59. 59 divided by what? 4. Okay, that is 14.75 milliseconds. Okay, so this is what? Average turnaround time. Okay, this is what? Shortest job first preemptive. Let us apply it to the same problem. Now we will apply what? Shortest job first non-preemptive will apply. Okay. Now let us apply to the same problem, to this problem only, non-preemptive version of shortest job first. So according to this what? So now let us take again the Gantt chart for this Gantt chart. So 0th millisecond. 0th millisecond, which one arrives? At 0th millisecond, only one process arrives, P1. So that is a P1, it arrives. Okay. At the second millisecond, but second millisecond process P2 arrives, but it requires only 8 minutes. But we don't have a choice. Because in the non-preemptive means once we start any process, it should continue till it completes its execution. We cannot stop in between. So I have to complete P1 only. So P1 it requires 20 milliseconds. So 0 plus 20, 20. It ends at 20 milliseconds. Okay, no option. Now, by the time it completes, so the P1 is going to complete at 20 milliseconds. So by 20 milliseconds, remaining 3 process arrives. Second millisecond, third millisecond, fourth millisecond, already these 3 processes arrives. But we are at the time 20 milliseconds. By this time, all other 3 processes arrives. But by this time, I completed what? Process P1 I completed. Now we are remaining P2, P3, P4 is remaining. Out of P2, P3, P4, now which one needs shortest time? So 8, 5 and then what? 2. 8, 5, 2. So among 8, 5, 2, which process needs minimum time? P4. So I have to start P4. Once I start, even though next process arrives after some time, because much lesser, we should not stop in between. That is what the meaning of non-preemptive. So I started P4, it needs 2 milliseconds. So 20 plus 2, 22 milliseconds, and it ends, it completes. Okay. Once it completes, now remaining what? P2, P3 are there. Among P2, P3, 8 and 5, P3 requires shortest. Okay, this is shortest. So P3 have to start P3, but it requires how much milliseconds? P3 requires 5 milliseconds. So 22 plus 5, 27 milliseconds. So now this also completes. So now I don't have any option, only process 2 is there. So I have to start this one, and this will require 8 milliseconds. So 27 plus 8, 35. See, the last time the Gantt chart 35, here also 35. Last time is we apply whichever the algorithm, the last time should be the same in the Gantt chart. Now we written the Gantt chart. From this, now I have to write the waiting time column and turnaround time column for each processes. Okay. Now, because these 3 common, this is the given data. Now, this we need to calculate. Now, let us calculate waiting time of P1. P1 starts at 0. Correct? P1 starts because there is no second occurrence, because we are not stopping in between, because it is a non-preemptive. So, yes, P1 starts at 0. It arrived at 0. So 0 minus 0, 0 millisecond. That is process P1 doesn't wait at anything. So next we started P4. P4 starts at 20. P4 starts at 20 millisecond. But P4 arrived at what? 4th millisecond. So P4 arrived at 4. 20, it starts at 20. So 20 minus 4, it is 16 millisecond. It waited. Similarly now, next P3. P3 starts at what? Sorry, P4. It is P4 it is. Right, P4 it is 20 minus 4, 16. P4. Next P3. P3 starts at 22, but it arrives at what? P3 arrived at 3 milliseconds. So 22 minus 3, 19. So this is P3, 19 milliseconds. So finally P2. P2 starts at 27, but arrived at 2. So 27 minus 2, 25. This is the waiting time of the individual process. Now we need to calculate the average. So divide by 4. 20, 30, 40, 46, 55, 60. So 60 divided by 4, that is again 15 milliseconds. So average waiting time is 15 milliseconds. So it is increases. because it's a non-preemptive. When compared to the preemptive, non-preemptive 15 milliseconds, whereas preemptive scheduling job 66 milliseconds. See, so that is how preemptives are always efficient. So next turnaround time. Turnaround formula is what? Total waiting time of the process plus execution time. 0. Process P on 0 time, but it gets 20 time. So it is 20 plus 0, 20. So within 25 plus 8, 33. 19 plus 5, 24. 16 plus 2, 18. Now add all these things. 8 plus 4, 12, 15. 1 carry, 3, 6, 8, 9. So 95 divided by 4. 95 divided by 4, I will get 23.75. 23.575 milliseconds. Much higher when compared to the shortage job fast preemptive. Okay. So this is what is the difference between shortage job first, preemptive, non-preemptive. This is a preemptive, non-preemptive. So common thing is, differences is in non-preemptive only one occurrence. In the preemptive, we may get multiple occurrences according to the given data. Okay. So in the non-preemptive, even once we started, after some time, even though next process arrives to request less time also, we should not stop, we should keep continue. That is the non-preemptive. Whereas in the preemptive, once we started any process, after some time some other process arrives and that process, newly arrived process requires less time, we have to stop the currently executing process and we have to switch to the next process. Okay. So this is what the non-preemptive and preemptive. I showed how shortage job first will works for preemptive and as well as non-preemptive. So suppose if you have any other problems other than that, and if you are not understanding, please post in the comments. I will definitely have an answer. So thanks for watching. Thank you.